Welcome back to the channel. So today's question is implementing stack using queue. So I will talk about how I think about the intuition part. Suppose I have a stack. I will tell you from how stack performs. Then we will understand how we implement queue for solving this question. Suppose stack has values 1, 2 and 3. So when we have to perform the pop operation in a stack, suppose this is our stack as st and we want to perform st dot pop, then this will just give us the top element. We got the top element here, and this removes from the stack. So same goes for the peek operation. Why I am telling peek and pop operation? Because these are the one where you have to think about the intuition. In push and is empty operation, they are just simple. You can get them directly from the code part. So now talking about the peek operation, if I perform the peek operation, it just gives us the 3. We do not remove 3 from here. So that's the thinking of solving the stack using stack. Now let's say this is our queue and this has values 1, 2 and 3. So in order to perform the pop operation, if we apply pop in the queue, it will give us 1. It will give us 1, and if we want, but we do not want 1, we want 3. But accessing 3 from the top, it's not possible. It's give us the front element always. So how do we access 3 in the front? It's not possible to access 3 directly. So let's think about performing this with the help of an extra queue, which is Q2. Now if I perform the push operation in the queue, it will transfer element to the another queue from the front, which is look like one is transfer here and it's got pop out from the queue. Now similarly for the 2 and for the 3. But here you can see that Q2 is similar to the queue, but we do not want this. We want to access 3 from the queue. How is this possible? Let's reperform this. We push 1 here and remove it from this here. Now for 2, now look at here, we got 3 alone in the queue, so we can directly access 3 from the queue. How? Just say q.front. This operation will give us 3 directly, and we can perform q.pop to remove this from the queue. Same goes with the peek operation, q.peek. In this we do not have to perform the pop operation. We can directly perform q.front in order to gain this element which we are required. So that's the intuition of performing q.peek and q.pop. Now try run through an example. We have given the input my stack, and now we have to push 1 on the q1 and similarly push 2 into the q1. Now it asks for the top operation. So in the top operation we have to just gain the top element of the queue stack. So for the top element of the stack is 2, but we cannot directly access 2 in a queue. So we just perform the similar I told you in a pop operation. So here top means peek, so we are performing the peek. How peek works? So just do nothing, transfer 1 to the q2, pop it out from the q1. Now you can see that the size of q1 is 1. So when we got the size 1, so it is a top element present in the q1. So now we can perform the q1 dot, which will give us 2, and we will return this variable directly. So we gain the 2 here, and then we transfer it back to the q2. Now after performing this, transfer all this element back to the q1. Now perform the pop operation. Similarly perform the pop operation that I told you earlier in the intuition part. Do nothing, just transfer it to the q1. When you get the size q1 equals to 1, just pop it out from the Q1 and return it to the function and remove it from the vector, from the stack. Now transfer this element back to the queue. So that's how you are going to perform this operation into the queue. Now moving towards the code part. For the push operation, just directly push it into the Q1. For pop operation, as I told you, transfer its element to the Q2 until the size became equals to 1 and store that front element into the val variable and pop it from the Q1 and transfer all the element back to the Q1 from the Q2 and return the value that we have stored here. So in the top operation, we are just gonna perform the similar one. Pop the element from Q1 until its size become 1. Take the front element from the Q1 and store in the variable val. Now push that element back to the Q2 and pop it from the Q1. Now coming to the time and space complexity. For the push operation, as you can see that we are just directly pushing it into the queue, so its time complexity is big of 1 and its space complexity is also big of 1 because we are not using extra space for storing the variables. For the pop operation, we are iterating over the queue and transferring to the another queue, so it takes big of 1 operations and we are using extra space of big of 1 apart from the given queue. And similarly goes for the peak operation, and is empty is a big of 1 operation as it is not taking extra space and time. Thanks for watching. The code is in the GitHub link.